So the first kind of definitions I want you to think about is great circles and small circles. See if you can recall what they are. So our great circles are a cross-section of a sphere where the radius is equal to the sphere. So great circles are our largest possible circumference. So we're thinking like our biggest possible flat slice. So that's what we're thinking. Whereas our small circles are any circle with a radius less than that of a sphere. So let's pretend this model is Earth here. So have a look at this grey plane here. If this was the Earth, this would be our equator. That's our horizontal kind of line or ring around the Earth that we call our equator. So the equator is an example of a great circle because it's one of those biggest possible flat slices. And this red line here is actually also an example of like a great circle because it's a sphere. That flat slice can kind of be spun like any way around the sphere. But that's not really relevant when we're looking at like latitude and longitude, but that's just to illustrate like what a great circle is. When we're kind of coming back around to our small circles, like this blue line here, that's a small circle. We're thinking back to how it's any circle with a radius less than that of the sphere. We can kind of see that as soon as we move away from anywhere that would give us that largest possible circumference, we're kind of left with all of these smaller circles, which ironically and conveniently are called small circles, and I've color coded it there as well. So that's our great circles and our small circles. So let's move into latitude. So we've got our latitude and our longitude. So what they are is their coordinates. Latitude is a coordinate for the position of like how far north or south you are from the equator, and then longitude is how far east or west you are. So again, if we think about it like if this is our Earth, our latitude coordinate, which is like a number with like a degree sign at the end, our latitude is okay, how far north or south am I going? So if it's like up a bit north, okay, I'm coming up here, and then how far east or west is it? Or if it's like east, or if it's like west, or I might have that the wrong way around because I'm trying to do it the other way. But that's kind of the essence of what I'm trying to say. So if we're thinking about our latitude, we're looking for like an invisible kind of reference point somewhere on the Earth that's like how far north is it, how many degrees north is it, or how far south is it. And then once we come down south, we can kind of go east and west. So think about it like this. Think about it like grid paper. If you trace along grid paper, you can go, okay, I could go 5 squares up. Think about there being like almost invisible grid paper all over like the Earth, and you're tracing up. So, okay, it's this far up and then this far across. And then that's how you can kind of like pinpoint where the location is in terms of latitude and longitude. So the lines of latitude are actually mostly our small circle. So our lines of latitude are like, think about all of these like crazy amounts of like invisible small circles that are running parallel to the equator. And because they are where they are, they can measure how far north or south we are. So this, for example, by measuring from like the center of the Earth up to here, by measuring like this angle of elevation, we can see how far north this point is like from the equator. So lines of latitude are our small circles parallel to the equator, and the equator is also kind of like a line of latitude. So if we're talking about the only kind of like latitude circle that's a great circle, that's the equator. The rest of our latitudes are all our small circles. So again, latitude, we're thinking how far north or south. So latitude, always north and south. And the equator, again, only line of latitude, that's a great circle. And the latitude, like I said earlier, is the point of elevation or depression from the plane of the equator, again, which measures how far north or south you are. And lines of latitude are also sometimes called parallels of latitude. They're referring to the same thing. Okay, so I've just got my one illustration. So here we can see our diagram is Earth's front view showing parallels of latitude and the center of the Earth. So this, if we're looking at this as our Earth, this is our equator. So you can kind of start to see how we use our circles, or like our lines or our parallels of latitude to kind of get those coordinate points. So this, if I had a point like here on the Earth, it's at like 0 degrees latitude, it's on the equator. Whereas if I have a point that's down here, we can see that we measure that as 30 degrees south, because our angle of depression is 30 degrees. So it's 30 degrees south of the equator. If I had a point that was up here, if I drew that in there, let me just make it nice and visual. So if I had a point that was here that I was trying to figure out like what the latitude was, you can again think like draw that invisible line up from the equator, and we see that the angle of elevation, you can see here that it's 60. So that's 60 degrees north. So if I had a point here on the Earth that I was trying to like define in terms of latitude, I would say it's 60 degrees north. And then like a point, so any point like on this latitude circle, oh, that's a terrible drawing. Let's just get rid of that. But anything, because the Earth is a sphere, it's 3D, we've got this line of latitude. Any point around the Earth that's on this 30-degree line is going to have a latitude value of 30 degrees south. So hopefully that makes a little bit of sense. And then the other side of the coin, we have our longitude value. So lines of longitude are semi-great circles. Yeah, let me pull up my visual. Oh, it's on the next slide. That's okay, we'll go back. So these are our lines of longitude, and they're called semi-great circles because they're only half circles. So we've got this, and then there's a corresponding other half of the great circle on the other half like of the Earth, but we're only really interested in like this side. So you can kind of see how all of our lines of longitude are semi-great circles. Have a look at that there. So lines of longitude are semi-great circles, referring to half a great circle, and they run between the north and south poles, like we saw in the previous slide. So they measure how far east or west you are from the prime meridian. So when we're talking about latitude, north and south, our kind of invisible reference point is actually the equator, but we don't have kind of like a vertical equator. So we've made up like this invisible point of reference that's called the prime meridian. So when we're talking about east or west in longitude, we're talking about how far east or west is a point from the prime meridian, which is our line of reference. And fun fact, that's like the 0 degrees longitude, and that line actually passes through Greenwich, England. So fun fact that might come in handy. And the lines of longitude are sometimes called meridians of longitude. So you might hear it referred to as like parallels of latitude and meridians of longitude. Again, just other names that we're using. And the international date line, which is 180 degrees, so it's opposite the prime meridian. So the prime meridian is our 0 degrees longitude, and the international date line is our 180 degrees longitude. And again, meridian, why they're sometimes called meridians of longitude, is because it's referring to that semi-great circle. So you can see here, like I said, this is like a front-on view of like the Earth. This is kind of a top-down view, so it might take your brain a second to wrap around like what we're looking at. But here we can see we've kind of got our prime meridian here, our 0 degrees. And then here, as we're moving right, you can see now we've gone 30 degrees east, 60 degrees east, 90 degrees east, 30 degrees west, 60 degrees west, 90 degrees west, until we wrap around all the way to the back, which is illustrated on this one over here, and that's our 180 degrees, which is our international date line. And then this is our prime meridian, our 0 degrees, which we can see here as well. And you can see there it crosses through Greenwich and England. So that's just to help out with your geography a little bit. So you can see that as we go around here, we go 30 degrees east, 60 degrees east, 90 degrees east, 120, 150 degrees east, and then a background at 180 is the back, which is kind of just like where east and west merge. So that hopefully will help illustrate that in your head a little bit more.